Hello everyone, and thanks for coming. And today we are going to share the topic, red light in the factory from 0 to 100 OT adversary emulation. So before we start, I would like to introduce ourselves. I'm Vic Huang, which is a security engineer and also an independent researcher. And this is my first time to speak in the venue since 2020. It's my pleasure. And he is so young. He is associate engineer from III, and he also interested in OT security and crypto. And also he shared his research in the conference before. So here's the outline. First, I will quickly go through the introduction of ICS, IT, and OT, and also adversary emulation. Next, we will review and analyze the ICS malware defined by MITRE and make a conclusion for our automation. Then we will use this conclusion to make our OT adversary emulation tool. And in the last part, we will have demos about 2 examples. So for the ICS, there are 2 important parts in ICS, SCADA and DCS. So the main difference between DCS and ICS is, first, DCS is more complicated and delicate on device control and access control. The second, instead of using private, or you can say customized control protocols, SCADA is mostly using public control systems. So most of the research is in the SCADA, and because it's easier to get information and devices on SCADA. Next is IT and OT. So generally, people use Purdue model to define the IT and OT in ICS network. So from there, level 4 and level 5, the top of the graph, is IT. So there are PC and also the web server. And from the level 3 below is operational technology system, OT. So especially from level 2 below, they are special. They are devices and controlled by special control protocols. And then I will introduce about adversary emulations and the existing tool. First, this is the MITRE ATT&CK ICS matrix. So it's similar to the ATT&CK matrix, but it focuses on ICS attack. It uses the same architecture, TTPs. So from the highest level to describe the attacks, usually is a target of the behavior to the lowest lowest level is the procedure, is the details about the attacks to achieve a behavior. So one way to use the ICC ATT&CK ICS matrix is to do adversary emulation. So what is adversary emulation? It uses the known threat skills and also automation to find vulnerabilities in enterprise. And for adversary emulation tools, it's as known as bridge and attack simulation, BAS. So different from the attack frameworks like meta-exploit ICS modules and ICS exploit. They are more like toolkits. The adversary emulation tools focus more on automating the whole attack process. So there are dozens of existing adversary emulation tools in IT, and there are very few in OT because the devices and the the manufacturers are different. So they are more complex in the environment. So as I mentioned, we want to make OT adversary, and so before that, we have to get the knowledge from the known threat. So we review and analyze the ICS malware in decades defined by MITRE, and we will have a conclusion about the whole attack process in this part. So first, this is the overview of the ICS malware from 2010 to 2022. And starts from the famous one, StarNet, to the PLC Blaster, which is shared in Black Hat US 2016. It's focused on PLC proxy attack. And then the latest malwares like Pipe Dream and Industrial 2. So for its behavior and purpose, we divide it to 4 groups. The first is start from 2011. They focus on data steal. And then the malware started to have a modular design to target the multiple protocols device and also multiple functions in the same protocols like Triton. And next, start from 2017, there are dozens of ransomwares, which is focused on try to encrypt or to break the operations in IT and OT and focus on their Windows devices in IT and OT. And in 2022, there are Pipe Dream and Industrial 2, which is more complicated than before we have seen. It carry a lot of different kind of modules inside. So it's like a thief with more tools in his backpack. And if we focus on the control protocols they use, here's the trend for ICS malware from 2011, from a single protocol's target to multiple protocols targets. So it's more like a modular design toolkits. And then besides the summary we mentioned, we also focus on the attack patterns of these malwares. So basically they have 2 main targets. First, information collections on the device. And the second, break the factory or field operation. And if we talk about the behaviors of this ICS malware, there are 3 kinds of ICS malwares. First is worm. It's focused on spreading and information collection, like StarNets and Havix and even PLC blasters. And also the second one is ransomware. It focuses on finding the specific process on HMI and also IT and OT Windows process and try to encrypt it to stop the factory operation. And the last one is toolkits. So it's built in the several scripts, or you can say modules, to attack different protocols on different devices, like Pipe Dream. And then combined with our experience in incident investigation and a security check on the real factory. There are 4 points we want to share. First, only some malwares really attack or impact the devices, like POC and IEDS. I think most of you is already know about it. And rest of them focus on Windows attacks. And also, we saw some hard-coded IP address and the tag name in the source code, which is not normal because it means there should be a data leakage or an insider before the malware start to attack. And the next, actually PLC have 3 or 4 modes, depends on the manufacturers. And mostly it's like a run-only mode and program-only mode. And also you can program and run at the same time. But some of them need user to physically change the mode with the buttons. So if the POC is well configured in the run mode, this malware would have less operations to control them by, for example, try to download the malicious program on the POC. And the last one we want to share is normally in the factory, HMI, human interface to POC is deployed as one-to-one or one-to-multiple IP address binding. So which means the POC proxy-like attack, like POC blasters in the Black Hat US may not work because there is IP address binding. So we pick 6 of them, which target OT attacks, especially on protocol attacks, and map it on the matrix. So we try to reproduce and reconstruct their attack to make the tool. So for the summary of their behaviors and patterns, we make our own conclusions to extend the sense ICS kill chain stage 2, the execute. So the main targets of this attack process is for the data targeting. If you attacker can try to ruin the data that shows in human interface to make the human to make bad decisions or to trigger some protective actions. And for controlled targeting, you can try to send the mail form comment or other kind of resend the comment to ruin the devices and to make the devices to do strange actions. And then we start from the first stage. That first we want to discover specific targets. So you can use the different method to achieve it. And the first, for the data targeting, you can find your target by recognize the response of the packet. For example, Triton broadcasts the specific packet and wait for the specific response to find the device that it wants to attack. And for control targeting, you can use a norm function code to find the target. For example, if you want to find a Modbus device, you can use function code 17 or 42 to find your target. And in the next stage, collections, the attacker will collect the data or the status of the device to do the further attack. For example, like in the StarNet, it sniffed the centrifuge speed for 2 weeks, try to break the centrifuge. So, and in the Havix, it enumerates the OPC attack. So try to steal the attack value. And also in the VPN filters, it sniffs and records the packets from the Modbus protocols. And in the third stage is manipulation. So for data targeting, you can try to manipulate the data on the HMI screen to let human make wrong decisions or to manipulate the alarm to make the wrong protective actions triggered. And also you can manipulate the data to let POCs to do wrong code execution. For the control targeting, you can use CVEs or you can use some functions from the protocols to abuse or to damage or to stop the operations of the factory. So for example, in 2016, industrials use MMS in in IEC 61850 to damage the devices, and also Triton use the Tri-Station protocol to deploy the malicious code on the POCs. And the last stage is check and evasion. So attackers might try to check the device status to make sure the attack is succeed, or try to hide the fingerprint from the text. So for data targeting, for example, Black Energy use kill disk to clean up the Windows data, and Triton writes meaningless code to overwrite the written malicious code. And for control targeting, malwares will check the POC status. So Triton did check the POC mode before and after it do the attack process. So we got this 4 stages conclusion, and then we used this conclusion to make open source adversary emulation tools in OT. So it's Scarlet OT. So here's the POC marketing ranks. They are different POC manufacturers, and they support different protocols. And our goal is to support most of the protocols on this table. So the design core of the Scarlet OT, as we mentioned, for the 4 stages attack process, and also we are inspired by the MITRE ATT&CK evaluations for ICS in 2021. So we reconstruct and reproduce the malware actions by the same protocols or by other protocols. And also, I think generally, if you want to do, you want to simulate the red team's process, or you try to automate the red team process, the coverage will be super bad because human can make the decision or to do the attacks by their experience or knowledge. But if you do the automation, it's just only the fixed logic. So what we want to do is we want to make a flexible tools that you could do like pause or insert your manual commands in any time point in the whole process, or you can customize and add your own payloads, and also you can try to combine the different attacks, because in the same environment or in the different environments, the combination of the devices and the IT architecture are different. And also, we want these tools is for general purpose that we can you can use it to test or your defense solutions, and also it is mapping to the ICS matrix, so it's very super nice for training. So at first we want to make a framework by ourselves, but after we think about the all requirements we want, we make it on the as a Caldera plugin, which Caldera is developed by MITRE. It's an open source IT adversary emulation. So we build a plugin to that the Caldera can do the OT attacks. And for now, we support 10 protocols and 23 techniques. So here's a easy screenshot that we have made for, this is the example of the Trisis attack, that we have several steps from the discover to collection to manipulations, and also check and evasion. And then in the next part, I will invite my partner So Young. He will introduce that we try to extend and reconstruct the whole the attack from the malwares, and also we will have 2 demos in this part.
And next, we will show a case using 2 different ICS protocols, and every color explanation we will show our demo video. First, we want to talk about is IEC-61850. It is a standard used in electrical environment and have 3 protocols in it. One is NS protocol used to control the device. Another is SV protocol used to measure the device value. And the other is GOOSE protocol used to pass the event alert between ID device. Here we use GOOSE as an example. It is a protocol for broadcasting event. When no event happens, the SQ9 will increase. It will broadcast the all event all the time, and let the value of SQ9 increase. When new event happen, the SQ9 will reset to 0, and SQ9 will increase. What we want to do here is fake these 2 values. This is the structural diagram of GOOSE frame. Because we want to fake the value of SQ9 and SQ9, so we need to know its position in the GOOSE PDU on the right side of the slide. And GOOSE will put some information in the all data. We also need this information, but it is hard to know the all data means without analysis. But we know the GOOSE will pass the event. GOOSE will pass where the event happened or not, and will use the Boolean value to display. So we can simply by sniffing the tree for a period of time and flipping the content of the Boolean values to trigger an alarm. And in our past practical experience, when you triggering an alarm, it will let the upstream device do some control, because in general, the factory will do some control to handle the exception. So it means that we can indirectly affect the operation of the factory by triggering an error. And each time when we finish the adversary emulation, we will think about attack and defense. Here we use GOOSE as an example. From an attacking point of view, you can just send a left packet or change the value of SQ9 or all data. In micro-attack ICS, it is called spoof reporting message. And from a defensive point of view, you can just check where there are disorder or repeat between GOOSE packet or check source of packets. And this is our attack chain, and we will show our demo video. And this is our testbed. And now we start our adversary emulation. First, we will sniff the packet for a period of time. And when we find the GOOSE packet, we will do some analysis and change the value. And it will have a alarm. When alarm happens, the broken device will be red, like the median device. So now alarm happen, the broken device be red, and we can see our adversary emulation. It will show our attack finish, and when alarm happen, it will let upstream device do some control like this. It turn on. Now we introduce another case base. It is Mitsubishi electric device. On the right side of the slide is the official website. Is the product diagram of the official website. From left to right, the product functions are the least to the most complete. And the device we use is IQ-R series. And the protocol in it is Melsec. And here we use Melsec to briefly introduce our process of the process of our analysis of ICS protocol. First, we will read the official user manual and then map the function of each field to technique defined by MITRE ICS. We generally focus two parts. One is how to identify the ICS protocol, which is the green part of the slide, and the other is how to use the function of the protocol to control the device, which is the yellow part of the slide. The reference here is the yellow part we mentioned on the previous page. There will be three parts. One is the function call, another is device address, and the other is data group path. And what I want to explain here is how difficult we have in building automation, because device address will be different according to your testbed environment. So for the convenience of demo, we pre-analyze the protocol and know which value represents which device address. This is like most ICS security incidents that happen in the past, because some incidents hackers can precisely attack what they want to attack. So it means that hackers know some specific information in advance. But if you stand from the point of view of automation, under the condition that you don't know anything, you have to enumerate all possible failure cases and have no way of knowing what will happen after an attack. And here we will go through the famous ICS security in the past, which name is StarNet. We choose to use StarNet because it is a common attack chain on the ICS security incidents. The main attack process of StarNet is first to find cookie, then check version and read or write device address, and finally do some control to let the device do some abnormal operation. And we will use Melsec to reproduce it. And this is our attack chain. And now we show our demo video. And this is our testbed. And here is our HNI. And we start our adversary emulation. First, we will scan local network and want to find our cookie. And each time we find a cookie, we will recall its IP for the next attack. And then we check the type. And we know it's IQ-R series. Then we read the device address value. And we will recall it. It's the device address value. And then we want to write something. Here we want to change its SV. SV is the upper limit of device pressure. We want to let it higher. So when the value of pressure increase, it will over the limit and will let the device broken. So now it's 2.93. And 2.93 will be 6.72. And finally, we want to open the air compressor. And when it opens, it will be red. So air compressor is open. And we can see the value of pressure now is 0.6, and it will slowly increase. And when it over the limit, it will let the device broken. And finally, we want to call about our opinion of use such tools by company. We believe that no matter what emulator you use, there are basically three kinds of attack. One is CVE, another is use some way to let device cannot work, and the other is use the function of ICS protocol to do some abnormal operation. And when you use such tools, it is hard to know what impact it will have on the factory. So we think that maybe you can use Digital Queen as a clone of the factory and could help you with adversary emulation. Although there are still many challenges, we think it will be a trend in the future. And here is a summary of our speech. First, we call about background knowledge of ICS and adversary emulation. Then we summarize the behavior of ICS malware. Then we propose 4 stages and use data and control these 2 parts on the point of view to explain. Then we use 2 different ICS protocols to demo our adversary emulation. And finally, we call about our view on use such tools. And thank you for your listening.